Hi, today you and I are going to study quadratic equations. This tutorial only covers the introduction to quadratic equations. In future tutorials, we shall see ways and means of solving quadratic equations and how to analyze them and use them in our daily lives. In this tutorial, we shall see the general form of quadratic equations, then we'll move on to the properties of quadratic equations. Then we shall try to represent quadratic equations on a graph and study its properties. And along the way, we'll keep taking some illustrations to make the process more enjoyable and understandable. Then came the Greeks. The much famed Greek civilization produced one of the world's greatest mathematicians, Euclid. He devised a method for finding lengths, which in our present day terminology are solutions to a quadratic equation. This is a piece of parchment found from his book, which was unearthed near Greece, and it has clear forms of the method he used to solve the quadratic equations. Solving of quadratic equations is often credited to the ancient Indian mathematicians. In AD 598 to 665, a great Indian mathematician Brahmagupta gave an explicit formula to solve a quadratic equation of the form ax square plus bx plus c equal to 0, which is the standard form of a quadratic equation. Here a, b, c are constants, while x is the variable and the highest power in the equation is 2. In AD 1025, Sridharacharya, one more great Indian mathematician, derived a formula now known as the quadratic formula. It is as quoted by Bhaskara too, for solving a quadratic equation by the method of completing the square, which you will study about in the next tutorial. So what is a quadratic equation? Let us try to understand with the help of an example. On the eve of your school's silver jubilee, it is decided that a new prayer hall shall be built for you people. After careful survey work, it is decided that a carpet area of 300 square meters would be required to accommodate all students. If the constraints are such that its length is 1 meter, more than twice the breadth, what should be the length and breadth of the hall? Let us try to depict the problem pictorially. This will help us understand better the problem in hand. Look at the picture. Here is a playground whose area is 300 meters square. Its breadth is represented by x here, while the length is represented by 2x plus 1 according to the given constraint. As shown in the figure, from the figure I can say x denotes the breadth of the hall in meters and 2x plus 1 denotes the length of the hall in meters. Please mind the units, for they are often a source of mistake. If you recall from your previous class, area of a rectangle is given by the multiplication of its length and its breadth. So we have area of the hall is equal to length of the hall into breadth of the hall, or 2x plus 1 into x. If you recall, x denotes the breadth and 2x plus 1 denotes the length. Which is equal to 2x square plus x meter square. So from the information given in the question, I can say 2x square plus x equal to 300. or 2x square plus x minus 300 equal to 0. This is a typical quadratic equation. On solving this quadratic equation, we can get the values of x and 2x plus 1, where again x is the breadth and 2x plus 1 is the length. We shall study about this in future tutorials. Moving. As seen in the previous example, it is necessary to understand and solve quadratic equations to deal with many real-life situations. They not only form a part of mathematics but also appear in other subjects like physics, chemistry, biology and social sciences. As this tutorial proceeds, we would cover the definition of quadratic equations, the various forms, properties of quadratic equations, and finally we shall try to represent quadratic equations on a graph and see how can we extract good from it. Through the process, I urge you to solve along with me. Note down important definitions and queries for future reference. Through this process, you are expected to cooperate and learn as you see this tutorial. In later tutorials, we shall explore ways of solving quadratic equations. So let us try to define a quadratic equation. In general, any equation of the form px equal to 0, where px is a polynomial of degree 2, is a quadratic equation. But we are interested in the standard form. If we write the terms of px equal to 0 in descending order of the degrees, then we have an equation of the form ax square plus bx plus c equal to 0. If you note, the terms are in descending order of the degree. The leftmost term ax square has a degree 2. The second term bx has a degree 1, while c has a degree of x equal to 0. So this equation is the standard form of a quadratic equation. Note that in the equation a should not be equal to 0. If a is equal to 0, then the equation becomes linear and no longer remains quadratic. Let us take one more example. John and Shaun together own 45 computer games. Both of them have played and finished 5 games each, and the product of the number of unfinished games is 124. The teacher is concerned with the drop in performance and wants to find out how many games they had to start with. In the problem, let us try denoting the number of computer games John owns by x, then the number of games Shaun owns can be denoted by 45 minus x. Now, how did this come? Let us try scratching our brains. Because the total number of computer games is 45, if one owns x, the other must own 45 minus x games. Number of unfinished games for John after he has finished playing 5 games is equal to x minus 5. Similarly, number of unfinished games for Shaun after he has finished playing 5 games should be equal to 45 minus x minus 5, or 40 minus x. We already know from the question that the product of unfinished games is 124. Therefore, the product x minus 5 into 40 minus x should be equal to 124. Let us try to simplify this question. Take a paper and a pen and try solving this along with me. On simplifying this, we'll get 40x minus x square minus 200 plus 5x equal to 124. On further simplifying, we get minus x square plus 45x minus 200 equal to 124. In the previous step, we added 40x and 5x. Let us take 200 on the other side. we get minus x square plus 45x minus 324 equal to 0. This is a quadratic equation, but let us not keep the coefficient of x square negative. Multiplying the whole equation by minus 1, we get x square minus 45x plus 324 equal to 0. Thus, the number of unfinished games John had satisfies the quadratic equation x square minus 45x plus 324 equal to 0, which is the required representation of the problem mathematically. In the next tutorial, we shall explore different means to solving this quadratic equation. Consider this example. A boy burns a certain number of calories in a day. The quantity of food consumed in a day in grams was found to be 55 minus the number of calories burnt in a day. If on Sunday the total food consumed was 750 grams, we would like to find out the number of calories burnt on that day. Let us try to formulate a quadratic equation for the above case. We have the following approach. Let the number of calories burnt on that day be x. Therefore, the quantity of food consumed on that day would be 55 minus x. If you read the question again, you would notice this constraint. From the information given in the question, the total quantity of food consumed on that day would be x into 55 minus x. Now this is equal to 750 grams. Let us try to simplify this equation. I get 55x minus x square equal to 750. Taking 750 on the left hand side, I get minus x square plus 55x minus 750 equal to 0. If you observe, I arrange the terms in descending order of the degree of x. Multiplying the whole equation by minus 1, I get x square minus 55x plus 750 equal to 0. Therefore, the total number of calories burnt on that day satisfies the quadratic equation x square minus 55x plus 750 equal to 0. Let us look at one more example before we move further. I want you to check whether the following polynomial equations are quadratic in nature. I hope you're writing with me. Let us take the first problem. X minus 2 whole square plus 1 is equal to 2x minus 3. Consider the left hand side of the equation. We have x minus 2 whole square plus 1 on the left hand side. Let us try to open this. We get x square minus 4x plus 4 plus 1, or x square minus 4x plus 5. Hence we can write x minus 2 whole square plus 1 as x square minus 4x plus 5. If you recall from a few seconds back, we just did this. Substituting this in the left hand side of the first problem, we have x square minus 4x plus 5 is equal to 2x minus 3. Now the first step we should do in this situation is take all the terms on the right hand side to the left hand side. Hence we get x square minus 6x plus 8 equal to 0. Now this polynomial equation is to be tested if it's quadratic or not. As the equation is of the form ax square plus bx plus c equal to 0, the given equation is quadratic in nature. If you compare, here a is 1, b is minus 6 and c is plus 8. Now let us look at the second part of the problem. Take the left hand side of the equation. It can be written as x plus 2 whole cube, which is the same as x cube plus 6x square plus 12x plus 8. Remember, a plus b whole cube is same as a cube plus b cube plus 3a square b plus 3ab square. We just apply that formula to get the above equation. So we have x cube plus 6x square plus 12x plus 8 equal to x cube minus 4. I just substituted the above equation into the problem. Taking everything on the left hand side like before, 6x square plus 12x plus 12 equal to 0 is the resulting equation. Now we must test it if it's quadratic or not. Before doing that, let us simplify into lowest terms. We get x square plus 2x plus 2 equal to 0. We arrived at this by dividing the above equation by 6. As the equation is of the form ax square plus bx plus c equal to 0, the given equation is quadratic.